Welcome to the debate. We often operate under the assumption that the universe is a container, a vast, empty stage where particles act as the performers, moving, colliding, and interacting. But what if the stage and the actors are actually the same thing? Today, we're dissecting a manuscript that proposes exactly that. We're looking at Supersymmetric Geometric Quantum Mechanics, or SGQM, and the Aetheron Model by Aaron Buscemi. And this isn't just a slight modification to the standard model. It's a proposal to fundamentally replace our concepts of particles and movement with a deterministic 12-dimensional geometry.
And that is a massive undertaking. I'm glad to be here, though. I have to say, my skepticism meter is redlining right out of the gate. We're talking about a model that challenges general relativity and quantum mechanics, the two most successful, battle-tested theories humans have ever produced. This manuscript essentially argues that light doesn't actually travel and that matter is just, knotted space? While the mathematics of this Aetheron is undeniably elegant, my role today is to stand firm on the side of empirical evidence. Does this add actual insight, or is it just complex geometry masquerading as physics?
That is absolutely the right question to ask. But consider the context. We've been stuck for decades with the vacuum energy catastrophe, where our calculations differ from observations by 120 orders of magnitude. We have dark matter that we can't find, and we have a total failure to unify gravity with the quantum world. So my position is that the Aetheron model offers the missing geometric bridge. It solves the unification problem through this Aetheron lattice and a radical concept called the non-propagation hypothesis.
And my position is that while those problems are real, the solution can't be to simply rewrite the definitions of reality to fit a geometric ideal. Look, reinterpreting the speed of light as a synchronization rate and gravity as a geometric response is fascinating on paper, but it has to survive the harsh reality of experimental data. I want to know if this 12-dimensional structure actually solves these problems, or if it just creates a beautiful, unprovable mathematical cage.
Okay, let's start with the foundation then. The current standard model treats particles as point-like excitations in a field. It's probabilistic. SGQM flips this. It defines the Aetheron not as a particle, but as a dynamic, 12-dimensional rotational manifold. The text defined this mathematically as M112, which is our familiar 4-dimensional spacetime, M4, crossed with an internal 8-dimensional fiber, F8.
Right, and we see higher dimensions in string theory, of course. But usually those dimensions are curled up so small they don't really matter. Here, the author seems to imply they're doing all the heavy lifting.
They are doing all the lifting. The central pillar of this work is the Aetheron theorem, or the SGQM invariant. The formula is alpha squared equals mu squared plus E rho squared. In natural units, this states that the fine structure constant squared is equal to the mass term squared plus the rotational energy squared. This is, it's profound. It implies that mass and energy are not separate entities. They're orthogonal projections of a single rotational state, the hypotenuse, which is alpha.
I'll grant you the idea that the fine structure constant, which is roughly 1/137 and has puzzled physicists for a century, is a geometric hypotenuse, is aesthetically very pleasing. It gives a reason for the number, treating it as a necessary relationship rather than an arbitrary constant we just measure. But saying mass is a projection is one thing. Physics is about mechanism. How does a geometric projection create the sensation of a solid object?
That brings us to the nature of the particle itself. In SGQM, particles aren't point-like objects or probability clouds. They are Aetheron knots, stable topological excitations. The text details that a fermion, a matter particle like an electron, requires a specific 720-degree rotation, or 4 pi, to return to its original state.
Which, to be fair, is a known property of spinors in quantum mechanics. We know that if you rotate an electron 360 degrees, its wave function comes back negative. You have to rotate it twice, 720 degrees, to get back to the start. But usually that's treated as an abstract property of the math.
SGQM argues it's not abstract, it's literal geometry. It introduces what it calls a dual boson structure.
The model posits that a fermion is actually composed of two orthogonal 360-degree bosonic rotations occurring simultaneously within that internal F8 fiber. It's not about mashing two particles together. It's about the internal geometry of the rotation. One 360-degree cycle isn't enough to return the manifold to its original state because of the complex dimensionality. You need two orthogonally coupled to close the surface.
I'm sorry, but I just don't buy that without more explanation. A fermion is matter. Bosons are force carriers. They follow completely different statistical rules. I mean, fermions can't occupy the same state. Bosons love to pile up. How can you build a fermion out of two boson-like rotations?
That's where the internal axes come into play. The model breaks down the internal dimensions into R-axes, labeled R1 through R8. Mass arises specifically from persistent curvature along the R3 axis, which they call the mass coupling axis. The particle we see is just the projection of these rotating axes into our 4D view.
This R-axis classification is incredibly specific. R3 is mass, R2 is charge phase. It feels a bit like assigning roles to actors in a play. How does this rotation create what we experience as physical inertia?
It uses what's called a projected activation sequence. As the Aetheron rotates through its 720-degree cycle, different axes project their influence into our observable space. The manuscript describes a flip mechanism. Imagine a triangle rotating in higher dimensions. We'll only see a 2D shadow of it. As it rotates, the shadow flips horizontally and vertically. These flips maintain the invariant alpha-2. Inertia, or mass, is the resistance to changing that internal rotational state. It avoids the need for a Higgs field to bestow mass. Mass is simply intrinsic to the knot's geometry.
That is a compelling argument for mass generation, I'll admit. If you accept the geometry, the mass comes for free. But let's move to the elephant in the room, or perhaps the lack of an elephant, the non-propagation hypothesis.
I thought we'd get here. This is the radical pivot.
It's not just radical, it's destructive to our intuition. The manuscript claims light doesn't travel. It says c, the speed of light, isn't a velocity. If it's not a velocity, what is it?
In SGQM, c is defined as the universal rate of rotational synchronization. Let's use an analogy. Imagine a giant stadium screen, the kind made of millions of LED pixels. If you see an image of a bird flying across that screen, is there a physical bird moving from left to right?
No, obviously not.
Exactly. Pixel A turns on, then turns off. Pixel B turns on, then turns off. The movement is an illusion created by the sequence of activation. The speed of the bird is limited by the refresh rate of the screen, not by the momentum of the bird. SGQM argues the universe is the screen, the Aetheron lattice.
That works for a screen, which is a fixed grid. But the universe is a vacuum. We send probes through it. We see light from stars billions of light years away.
The model argues that light, or electromagnetic waves, is the emergent result of an orthogonal oscillation between mu, the mass or potential term, and E-rot, the rotational energy. If E-rot moves as a sine wave, mu moves as a cosine. They always maintain that Pythagorean total. The wave is just the Aetheron lattice updating its geometric state, sequence by sequence. It's not a photon flying across the room. It's a disturbance in the geometry propagating through the lattice structure, exactly like the signal moving across the pixels.
But we have the Michelson-Morley experiment from 1887. It famously disproved the ether. It showed there is no ether wind as the Earth moves through space. If this Aetheron lattice exists, why didn't they detect it? I mean, that result killed ether theory 140 years ago.
And that is the crucial distinction. Michelson and Morley were looking for a fluid ether, something like wind flowing over an airplane wing. They were looking for translational drag, but the Aetheron is a rotational manifold. The manuscript argues that the no result of Michelson-Morley is exactly what you should expect.
Explain that.
Because there is no translational drag. The interaction is purely rotational phase shifts. The Earth isn't plowing through a fluid, it's moving through a geometry that updates rotationally. The experiment failed because it was testing for the wrong kind of mechanism.
It's like trying to measure the wind speed of a shifting shadow. You can't measure the drag of a shadow because a shadow isn't pushing air. It's just a state of light.
That's a clever rebuttal. It insulates the theory from the most famous failure of ether theories. But let's apply this to gravity. General relativity is our gold standard. It works perfectly from the orbit of planets to the lensing of light. Why change it?
Because standard, general relativity breaks down at the quantum level. We can't make the math work when things get small. SGQM accepts Einstein's field equations but adds a rotational correction term. The equation becomes g mu nu plus f mu nu equals 8 pi t mu nu.
And what is that f mu nu doing? Is it just a fudge factor to make the numbers fit?
Not at all. It represents the internal torsion of the Aetheron. And here's a fascinating point. The model reinterprets the 8 pi factor in Einstein's equations. Usually, we treat that as just a geometric constant to get the units right. SQM says it's the synchronization constant. It represents the full 1440-degree, or 8 pi, closure cycle required for topological stability.
So gravity is what? A residue of this rotation?
Gravity is the emergent geometric response to maintain coherence across the lattice. When mass, which we established is a knot in the R3 axis, sits in the lattice, it demands a phase shift in the surrounding geometry to keep the equations balanced. That phase shift is what we perceive as curved spacetime.
That sounds very similar to GR, just with different vocabulary. Curved spacetime versus emergent geometric response. I need a testable difference. If this is science, it needs to predict something Einstein didn't. Otherwise, Occam's razor says we stick with Einstein.
And it does. The manuscript specifically cites Mercury's perihelion precession.
Einstein solved that. That was his big victory. The precession of Mercury's orbit couldn't be explained by Newton, but GR predicted it perfectly.
Standard physics says it's just curvature, but SGQM attributes it to magnetic leakage. Remember the RXEs? The Sun has a massive magnetic field which lives in the R6 axis. Mercury is in a very tight orbit. The model claims the Sun's R6 magnetic sector induces torsional drag on the curvature sector, the R7 axis.
So it's predicting a coupling between magnetism and gravity that GR forbids?
Exactly. It predicts that Mercury's precession rates should correlate with solar magnetic activity. It even references Messenger spacecraft data as a context for this analysis. If we analyze the data and find a correlation between solar cycles and the precise rate of precession, that would be evidence for the Aetheron model and against standard GR.
That is bold. Standard GR assumes the metric is independent of the electromagnetic field tensor in that way. If there's leakage between R6 and R7, that implies a unification we haven't seen. But speaking of things we haven't seen, let's talk about the biggest invisible thing in the universe: dark matter.
This is where SGQM really shines, in my opinion. It offers a geometric solution to dark matter without inventing new particles.
Everyone invents new particles for dark matter. WIMPs, axions. Why is this different?
Because it uses the axes we already have. It introduces dark bosons. These are Aetheron knots stabilized entirely within the bosonic axes, R5 through R8.
So they don't use the fermionic axes R1 through R4?
Correct. And that's key. The charge axes are R2 and R6. Because dark bosons don't use R2 or R6, they are electromagnetically silent. They cannot absorb or emit light. They're invisible.
But they have gravity?
Yes. They generate mass via the R7 axis, which is the curvature coherence axis. So you have a stable structure that has mass, R7, but no charge, R2, R6. It fits the definition of dark matter perfectly.
I'm not convinced by that line of reasoning, because stability is a huge issue. If you have a knot made only of bosonic rotations, why doesn't it decay? Bosons usually want to pile up in the same state. They don't form stable matter structures like fermions do. You can't just have a clump of bosons hanging around acting like a galaxy halo.
That's where the supersymmetric hinge comes in. The model describes the gravitino, a spin 3/2 structure, as a bridge. It links the fermionic and bosonic domains. It ensures the knot doesn't unravel. It creates a topological confinement for these dark bosons.
They're trapped in a high-stability winding state within the bosonic domain.
So you have these invisible knots of space, stabilized by a hinge we haven't detected, floating around generating gravity. It is internally consistent, I will give you that. But it relies heavily on this specific R-axis architecture being physical reality, not just a mathematical model.
It also explains the mass gap in the strong force. The manuscript defines a gap as the minimum rotational work required to sustain a closed 720-degree cycle. If you don't have enough energy to close the knot, the particle doesn't exist. That is a geometric derivation of a phenomenon that quantum chromodynamics just accepts as a fact.
I can't deny the appeal of deriving constants rather than measuring them. The idea that the fine structure constant alpha is just the ratio of the legs of a triangle in 12 dimensions is seductive. But we have to be careful. The manuscript talks about matter is trapped light. That's a poetic phrase, but is it physics?
It's the ultimate physics. If alpha 2 equals mu2 plus E rot 2, then matter, mu, is just light, E rot, that has been phase shifted into persistence. It's not poetry. It's the conservation equation. It's Pythagorean.
I suppose we're reaching the end of our time, but I have to summarize my skepticism here. This model is mathematically dense. It demands we abandon the idea of transmission, that things actually move from A to B in favor of synchronization. That is a massive conceptual cost. It requires us to believe in a 12-dimensional manifold we cannot see and an internal fiber that dictates reality.
I see why you think that, but let me give you a different perspective. Standard physics requires us to believe in dark matter particles we can't find, dark energy we can't explain, and a unification of forces that we can't mathematically achieve. SGQM asks us to trade those mysteries for a single geometric framework. It doesn't just describe the universe, it derives it from geometry. From the derivation of the fine structure constant to the explanation of the mass gap, it unifies physics under a single living geometry.
It is a profound shift, I will admit. The Aetheron theorem, linking mass and energy through hypotenuse, is a tool that general relativity lacks. Whether it's physical reality or a mathematical ideal, that remains to be seen. But the prediction about Mercury and solar magnetism, that's something we can actually check. And if that correlation exists, we might have to take this rotation much more seriously.
And that's the beauty of it. Whether the Aetheron is real or not, the concept that matter is trapped light, trapped rotation, forces us to look at the universe differently.
It certainly does. It invites us to consider if the universe is a stage for particles or if the universe is the actor itself.
A perfect way to put it. Thank you for listening to the debate. We hope this exchange has illuminated the complex, fascinating potential of supersymmetric geometric quantum mechanics.
Keep looking for the evidence.
And keep questioning the geometry of your reality. Goodbye.